All right, today we're talking about Chapter 10, Section 5, Annuities, Methods of Savings and Investments. Now, this particular section is extremely wordy, and it's also there's also quite a bit of uh, calculator computation here. And because of that, it's going to be one of those days where I do appear very lazy, and I'm just going to do a lot of snipping. And hopefully by now you know that's not the case, that I'm not lazy about stuff. It's just I like for things to look nice and neat, and you'll know what I mean when I actually get to the problems. Anyways, so let's talk about annuities. Um, well, I mean, there's really no other way to put it, but I mean, besides this, an annuity is a sequence of equal payments made at equal time periods. Also, if you have an annuity and you need cash now, you know who to call, right? Anybody remember those commercials? No, that's fine. Um, that's it. Do you remember the phone number? Yeah, 877 cash now. Yeah. Yeah, those are oh my goodness. The advertising for that fella worked. Anyways, so this particular problem, there's not necessarily a hard and fast formula for this. I mean, we obviously saw the annuities thing, but one of these problems we can just kind of honestly think our way through. And what I mean by that, well, let's read the problem first. The problem reads: You deposit $1,000 into a savings plan at the end of each year for 3 years. The interest rate is 8% per year compounded annually. Find the value of the annuity after 3 years. Alrighty, so what's going to happen is, well, after year one, we're going to put in $1,000. Okay. Well, it hasn't been in there for a whole year yet, so it doesn't get compounded. All right. Year two, it does get the 8%. So it's going to be $1,000 times 1.1.08%. Okay, and that's going to be $1,080. And then we also deposit $1,000 more dollars because it's the end of the year. Okay, so $1,000 times 1.08. Again, we're talking about just 8% here. That turns it into $1,080, and then plus an extra thousand. So we now have $2,080. So after 2 years, we have a whopping $80 more than we actually more than we originally had. All right. In the third year, all right, well things get a little bit better. So now we're going to have the $2,080, and again we're going to multiply it by 8%, which is actually pretty darn good. Uh, savings plan like that. That's the thing about these examples. Um, might be my only gripe so far about this textbook, but let me finish this real quick. So $2,080 times 1.08%, and then of course we deposit $1,000 more dollars. Okay, so 2080, 8%. I can't do that one too quickly in my head. So 2080 times 1.08, so 2246.40. Yes. Well, if we were to put 0.08, okay, so if we did 1,000 um, times 0.08 for 8%, right? Well, that is going to give us just simply $80 because 8% of $1,000 is $80. But we're putting the 1.08 to include the 1,000 in there, right? So now that becomes 1,080, and it's a lot faster than saying, okay, looking at this 8% interest on $1,000, so I do 80 plus 1,000, and that's just an extra step. Whereas you can just put 1.08 for 8%, and you're good to go. And we've seen this we've seen this in our formulas already, and I'm pretty sure it has it in this particular annuity thing right at the beginning. No, I'm not done. Hang on. Also, so notice how it says right here the principal and in parentheses 1 plus the rate. Well, it's 1 plus the rate of 8%, which is 0.08. So 1 plus 0.08 is 1.08. So I'm not doing anything complicated. I'm not doing anything magical. I'm just combining them right away. That's all. hmm Anyways, so the in my calculator I've got 2080 times 1.08. That is 2246, and then I add 2246 to 1,000, so I get 3246, and there's also 40 cents in there. Okay, so the value in my account after 3 years is going to be $3,246. Right? And the interest, obviously, if I had put in $3,000 because I put in 1,000 each year, then my interest is obviously going to be what my total is minus what I put in. And so I put in 3,000. My interest is going to be $246.40. Okay, and that's really it. We just kind of thought our way through it. We didn't really use any formulas or anything like that. This is one of the easier problems, but again, it does kind of you have to think about it. But I was about to get on my soapbox here. If anybody finds a savings account that gives you 8%, please let me know. This is incredible. Any savings account I see is like 1.5 or 2%. It's ridiculous. You might as well just stick it in the stock market and. I mean, stock market is just crazy right now. I mean, money is just being printed left and right. And yes, it does have to stop eventually. But the not only this textbook, but every other textbook that I teach out of, they always go a little too crazy in terms of savings accounts and all that stuff in terms of what percentage you have. But anyways, um, let's now get to this. So I was thinking, okay, so I could do this, and then I feel like it would be a little messy. Whereas if I just snipped it, since the numbers and letters are everywhere, I might could teach this better this way. So again, this is the perceivably lazy part, but hopefully you don't think that about me. At least not this far into the semester, because I have tried really hard. But here we go. So the value of an annuity, the interest compounded once a year. So again, the big deal with this is to understand what each individual um, variable is, right? So if P is the deposit made, so P is the deposit made, or we like to call it the principal most of the time, right? So P is the deposit made at the end of each year for an annuity that pays an annual interest rate R. Again, R, so far so good. We're not getting confused here. R is still rate. And it's compounded once a year. The value A of the annuity after T years is, and this is the formula. So again, we have an A, a P, an R, and a T, and of course another R. And we're told exactly what each one of those were. And all we have to do is the same thing we've done for the past like 3 sections, maybe more, I don't know, is just basically plug and chug, right? So example 2 reads, suppose that when you are 35, you decide to save for retirement by depositing $1,000 into an IRA at the end of each year for 30 years. If you can count on an interest rate of 10% per year compounded annually, again, that's bullcrap. But anyways, how much will you have from the IRA after 30 years? Yeah, maybe an IRA. Okay, maybe that's not. Okay, maybe I take that back. How much will you have from the IRA after 30 years? All right. Well, we are told the time frame here is 30, so T is going to be 30, and I guess I can do a little bit of writing here. So for this, T is going to be 30. We have the rate at 10%, which we're going to put 0.1. What else? We are depositing $1,000 every single year, and we're wanting to know the amount. So that's pretty good because again, there were four unknowns here, and we were given three. So all we have to do is simply plug those values into our equation here, and I guess okay, I take it back. So the second hardest thing might be to put this into the calculator correctly. The first hardest would be to line up your variables, and then the second hardest would be to put this into your calculator correctly. And I know that could be a devil because even I've done this. I've made this mistake multiple times in this class already, and it's quite embarrassing. I know, but stuff happens. But you put the values in, and then you'll end up with 164,494. Again, just simple plug and chug. All right. Well, it's wanting us to find the interest. All right, well, let's think about this for a moment. If we are putting in $1,000 every year for 30 years, all right, so that means we have put in $30,000, all right, which seems like a lot. That's because it is. Uh, well, my my IRA at the end of those 30 years is worth $164,494. So all we have to do is figure out, okay, well, 164,000 minus 494 minus 30,000. And so we see that my interest is worth, or my interest on this account was $134 and $134,000 494. And I mean that's pretty darn good. I mean for 30 years, um, I guess. But that is the arithmetic behind that. And good news, no, you will not have to memorize this. Furthermore, I've got look at this equation. I've never even tried to memorize this because it's always given to me as well. And this is going to lead us into our next equation, or next problem rather. And then now, hopefully, you see why I wasn't too much in a hurry to want to try and cramp all of this onto the page, especially whenever I write teeny tiny. Um, my pen and this program I'm writing on, they don't really get along. Alrighty. Well, before we begin though, let's go ahead and look at our formula over here. All right, so the value of an annuity, interest compounded in times per year. So on the previous examples, we were just compounding them at the end of the year, right? That's easy peasy. We're just compounding at the end of the year. However, we're going to compound them now, a certain amount of times per year. Something that we've seen before, along with our continuous compounding. So again, P is a deposit. Okay, so real quick, 1, 2, 3, 4, 5. So again, we have five unknowns, five variables, and we've seen this before, right? We've seen A, P, R, N, and T. We've always seen those before already. But and well, on top of that, they're what they represent doesn't even change from what we've been doing. So that's also a plus. The only thing difficult about this particular section is, well, the formulas get positively absurd. So where am I at? If P is the deposit made at the end of each year, uh, compounding at the end of each compounding period for an annuity that pays an annual interest rate R in decimal form, of course, compounded n times per year, the value A of the annuity after T years, okay, so T again is years, is this nice, clean, Humpty Dumpty formula. Okay. Well, let's go ahead and start this problem. So here we go. At age 25, to save for retirement, you decide to deposit $200. Okay, so 200 is going to be our P here. At the end of each month into an IRA that pays 7.5% compounded monthly. So that's two things told to us there. Well, one of them is that the rate is 7.5%, so 0.075, and then we're compounding monthly. Well, how many months are there in a year? Well, there are 12 months in a year, and that's three. So we need one more, and that's probably going to come in the form of A. So and there it is. So how much will you have from the IRA when you retire at 65? Okay, well, if I retire at 65 and I am 25, hopefully I can make it that long, first of all. My T is going to be equal to 40 because 65 is 40 years away from 25. From there, all right, again, we have 1, 2, 3, 4 of the 5 unknowns, and that's because the fifth one, the A, is what we're trying to figure out in A of example 3. We plug all of our values in, you do the computation, it gets very sticky, very fast. And then we see at the end of 40 years, we have $604,765. Right? And so we are now asked B to find the interest. Okay, so if we put in $200 at the end of each month, right? Well, $200 at the end of each month, and then we can do, pretty sure it's over there in the the white part, but if we did $200 each month, so $200 times 12 and then times 40 would get us $96,000. So in total, in 40 years, we have put in $96,000. Okay. All right. Well, we put in $96,000, and we saw that from A, we have $604,000 in our account. So we want to know how much interest we accumulated over the course of 40 years. So all we have to do is take the amount in the account, subtract how much we actually put in, and then we end up with $508,000. So interest worked for us for a change, and we ended up making $508,000 by, I won't say necessarily doing nothing, because I mean, I don't know about you guys, but I don't really have $200 to put into an IRA at the end of each month, much less for 40 freaking years. So yeah, I know, and it's another stupid example, right? I mean, heck, why don't we just deposit 1,000 every month? Um, but it's just it uses these numbers to really show the power of compounding, and the power of compounding is pretty good if you have the funds to actually abuse that power of compounding. Um, yeah. So next up is, I think, going to be the super duper wordy part. Oh wait, no, it's not. Not yet. Not yet. Okay, so next up, instead, we have um, another just outstanding formula, and I guess we can snip all this. Alrighty, so planning for the future with an annuity. Again, so our formula here, the regular payments needed to achieve a financial goal. So this is again kind of like the problem of how much should I put into an account that has X amount of interest if I want to have $20,000 at the end of 18 years. This is kind of like that, um, except a little bit different, obviously. So the deposit P, again, P, that's our deposit, that must be made at the end of each compounding period into an annuity that pays an annual interest rate, again, R, compounded n times, again, n is compounding, how many times per year, in order to achieve a value of $80 after T amount of years. So again, absolutely nothing changes. Every one of these formulas use the exact same variables that you're used to. It's just, like I said, this equation is so abusive. But it's one of those things, right? But I will tell you one thing. Um, these last two formulas I've never had to memorize in my life, but whatever. So, anyways, example 4, using long-term planning to achieve a financial goal. So, suppose that once you complete your college education and begin working, you would like to save $20,000 over 5 years to use as a down payment for a home. You anticipate making regular end-of-month deposits in an annuity that pays 6% compounded monthly. That is in freaking insane. So how much should you deposit each month? Round up to the nearest dollar. So again, I didn't do the thing where I uh, put my variables. I feel like I should. So we're wanting to figure out um, how much we need to deposit each month in order to get to that $20,000 goal. All right. So we're trying to find P. So the amount that we're looking for here is $20,000. All right. My interest rate was 6%, so my rate is 0.06 over 5 years. So T is going to be 5. Where else are we at? Down payments. Oh, there was there it is. End of month deposit and compounded month. Okay, so we're compounding monthly. So N is going to be 12, right? Because again, there's 12 months in a year. 1, 2, 3, 4. All right, I got 4 out of the 5 variables, and then you just again plug and chug. So again, looking at this particular formula, what does this tell us? Well, it tells us that um, with my goal in mind, I'm going to be depositing again well, I'm trying to figure out how much I need to deposit, rather. I'm trying to figure out how much I need to deposit at the end of each month into this account that compounds 6% monthly in order to have $20,000 to afford a house in 5 years. Well, I need to put in $287. And, that's not, it's not terrible, but you're not, I want to see these banks. I want to see where they exist. Um, but that's what we're looking for. So you deposit $287 each month to have $20,000 for a down payment on a home. All right, now I think we get to the super duper wordy part. Now, I was thinking how I should do this, and um, you know, maybe make y'all write a paper, maybe give you a little quiz over these bold terms. But then I thought, I ain't got time for that. Instead, if you could do me just one favor, uh, no quiz, no paper, if you don't mind, just give it a shot. Just give this a quick glance, give this a quick read, starting from investments, risk, and return. I mean, it looks very very wordy, but it only spans like 3 pages. Give it a read. I promise you, you'll be a lot more informed about this kind of stuff, especially nowadays since investing is so easily accessible to anyone. If you know what you're doing, you could try to make some money on the stock market, and being able to know those words and symbols really helps. So that's y'all's thing. If we were in a classroom though, you better believe I'd be making a write a paper. Anyways, so this is something we can do without actually, I don't think, having to snip anything. So now a lot of this stuff was kind of given to us on the previous page, and I'll talk about it also. But real quick, let's just go across this here. All right. So the 52-week high is basically, how high has the stock, in this case Disney, how high has it been in the last 52 weeks, and how low has it been in the past 52 weeks? What is the stock name? What is the symbol for the stock? What is the dividends for the stock? The yield percentage, the profit earnings ratio, the volume per the volume per 100 shares. What was the high today? What was the low today? What did it close today? And what was the change? That's what all that means. And I think everything is pretty much self-explanatory, with the exception of the dividend, the yield percentage, and probably profit earnings and volume. Everything else seems pretty self-explanatory, and I'll obviously cover those four, uh, hopefully, but enough. So use the stock table for Disney to answer the following questions. A. Okay, so what were the high and low prices for the past 52 weeks? Well, we were told that the high and lows are already on this ticker here, and it looks like 42.38 and 22.50 respectively. So we'll put high, um, 42.38, and then the low is 22.50. Okay. B, if you owned 3,000 shares of Disney stock last year, what dividend did you receive? So real quick, let's actually go to dividend, because I think that's something that we can cover. Here we go. So looking right here, the heading div refers to dividends paid per share to stockholders. So my dividend is paid per share, okay, to stockholders during the past year. All right, so going back to our problem here, if we owned 3,000 shares, the dividend is 0.21. What that means is that for every one share of Disney you own, you get 21 cents. And so the math is pretty simple. The math would be, you have 3,000 shares, and then you multiply it by 0.21. I get 21 cents per share. Let's see, 10% is 30, 20%, 60, then 1%, 30. So $630. Let me make sure. Yeah, $630. So if I own 3,000 shares of Disney stock, then I get a dividend of $630, and that sounds pretty cool, right? And it is, except for the fact that to own 3,000 shares of Disney, let's just say at the closing price here, 32.50, you would need a whopping $97,500. I'm really glad that you know. I don't know. I mean, I guess we all should own 3,000 shares of Disney. But yeah, so if we have $97,000 to put into Disney, we get 630 of it back in the form of dividends. But that's not including if the stock rises, and that actually segues into C. So what is the annual return for dividends alone? Okay, so we could do the math on this. Okay, we could do the math on this, and do the 630 divided by 97, whatever. But the thing is, these financiers, um, they take care of that for us. We're looking at yield percentage. Okay, so let's go back to the textbook and let's just see exactly what yield percentage is. So the heading yield percentage stands for percent yield. In this case, the percent yield is 1%. Okay, so what does that mean though? This means that the dividends alone gave investors an annual return of 1%. So the yield percent basically means what is the return. So my return, and again, it's in percents here, my return is 0.6%. Okay, and and I'll be honest with you, that sounds a lot more like what banks do, anyways. But it's 0.6%. So the first part of C, what is the annual return for dividends alone? It is going to be 0.6%. So how does this compare to a bank account offering 3.5% interest rate? Well, we can think about this in two ways, right? Obviously, the bank account offering 3.5% interest rate is better um, than the 0.6%. But you also have to account for the fact that Disney is a stock. It can go up and it can go down, right? So if the Disney stock goes up even just a little bit, and I mean this isn't the exact math, but just bear with me. If the Disney stock goes up, 3% over the course of a year, then you're already making a lot more than you are with that savings account. But at the same time, stocks go up and down, so don't invest money that you need immediately, right? Because I mean, in one year, looking at this, looking at the highs and lows here, you could you can make a lot of money or lose a lot of money really fast. But I would say Disney's a pretty safe investment, but as long as you don't touch the money for 5, 10, 20 years. So that's how that compares. I'm not going to write all that down. D, how many shares of Disney were traded yesterday? Okay, so looking at the shares, we're going to have to look at the volume here. Volume, and it says 100. So that means that this volume is multiplied by 100. All right, it doesn't mean 115,000 Disney stocks were traded yesterday. It means that 115,900 times 100 stocks were traded, or shares. I say stocks, shares were traded. Okay. So what you would do is you just say, okay, so 115,900 times 100. All right, and then we add two zeros onto the end of that, so we end up with um, 11 million, I believe. 11 million. Hang on. I don't know. For some reason, I'm lost here. Yeah. Okay, so 11,590,000, and there. So we traded 11 million stocks or shares. I keep saying stocks. 11 million shares, and there's a difference. Um, Shares are the pieces of stock that you share. And I don't think we're going to have room for E, F, G, H. So we can probably fit in E though. Try to fit E in here. So E, what were the highs and low prices for Disney shares yesterday? Well, again, they're given to us right there. So the high would be 32.50, and the low would be 31.25. Now let's snip it again. Alrighty, so F. What was the price at which Disney shares last traded when the stock exchange closed yesterday? Okay, so we can tell what the price was that last traded at by looking at the net change. And in this particular case, well, no, I'm sorry. No, I'm getting ahead of myself. Getting ahead of myself. We can just simply look at the close. What was the price which, yeah, we can just simply look at the close, which was right here, which was 32.50. G. What does the value or symbol in the net change column mean? Well, let's go back and look at our text. Net change, it makes a lot of sense. It's just basically a change from one day to the other. All right, so this over here is a symbol for FedEx. This is a change in price from the market close 2 days ago to yesterday's market close. The number is negative 160 right here, because that means that the share price is closed $1.60 less than it was 2 days ago. And so in this particular case, um, well, I guess it just basically means that the price of our Disney stock uh, didn't change at all. I mean, it went up, it went down, but it closed the exact same. And I don't really feel like writing all that, so we're just going to leave it blank. H. So compute Disney's annual earnings per share using our formula here. Annual earnings per share is equal to yesterday's closing price per share divided by the PE ratio. Okay, so it's as easy as it sounds, right? So what was yesterday's closing price? Yesterday's closing price was 32.50, right? And then we're going to divide that by the PE ratio of 43, and we end up with 0.75 or 0.76. So my profit earnings or my annual earnings per share is going to be 0.7576. There, 76 cents per share. It's my annual earnings per share. So again, looking at this ticker here, there's nothing too difficult involved in that. I don't think. Again, I feel like we covered the dividend, the yield, the profit earnings, and the volume. Everything else is pretty self-explanatory. It's made to be like that. Alrighty, so I think this is the last thing we're going to talk about here is more. Um, yeah, I don't think we need that. Again, this is more just information regarding your IRA stuff, and again, it's things that I mean I don't know. I just feel weird reading off the board here, especially when you have access to the textbook. You can read it. It's very important. If you want to take a class, again, I've said this so many times already in this course. If you want to take a class that you actually use in the real world, this information is very good, as well as the 3 pages that I was telling you about earlier. But anyways, uh, example 6. So suppose that between the ages of 25 and 35, you contribute $4,000 per year, and we're gonna have to use one of those silly formulas again. So I'll just go ahead and pull this in. Alrighty, so suppose between the ages of 25 and 35, you contribute $4,000 per year to a 401k, and your employer matches this contribution dollar for dollar on your behalf. The interest rate is 8.5% compounded annually. What is the value of the 401k at the end of 10 years? Okay. Well, again, looking at our problem here, we are told that we are putting in $4,000 per year. We're putting in $4,000 per year. Okay. But in our formula, in our formula, we're not going to put 4,000, right? Because if we continue, it says, and your employer matches, oh, that's not the laser. It says, and your employer matches this contribution dollar for dollar. Okay, so it's actually going to be $8,000. Okay, because $8,000 is being put into this 401k. Let's see here. The interest rate, right, our rate is going to be 8.5%, so that's 0.085, and it's compounded annually, so that's unfortunate. It's just going to be n is 1, and what is the value after 10 years? So t is going to be 10. Okay. So with all this in mind, all right, if we're going to be putting $8,000 into our formula. Our rate is 0.85%. We are compounding it just one time a year, and for 10 years. Right. Putting all this into our formula here, we end up with 118,681. Right. So that's pretty good. But B reads, oh, I didn't put C, but anyways, so after 10 years of working for the firm, you move on to a new job. However, you keep your accumulated retirement funds in the 401k. How much money will you have in the plan when you reach the age of 65? Okay, so all we have to do now is we take our money that we made, which is 118,000, right? And now our T, because we're at the age of 65, our T now is 30 years more than 35, right? Because it says after 10 years, so when I'm 35, I move to a new job. So 30 more years, that is my T, and then we do the arithmetic there, and we end up with $1.3 million. That's pretty good. I wish I would have had $4,000 per year to start contributing at the age of 25. Alas, I didn't. I don't know who these examples are, but they're not the normal person. I'll stop. All right, so C reads, what is the difference between the amount of money you will have accumulated in the 401k at the age of 65 and the amount you contributed to the plan? So again, the math here is we're going to take how much we have, we have been, what we got from the interest, and we're going to subtract how much that we um, put into our account each year. Okay, so if we put in 4,000 each year, well, $4,000, and that's interesting. One moment, let me read this real quick. Hmm. Okay, yeah, I misread that. Okay, so yeah. So what is the difference between the amount of money you will have accumulated in the 401k at the age of 65 and the amount you contributed in the plan? All right, so keep in mind that from the age of 35 to 65, I just let the stock market do the work. I did not throw another dime into my retirement plan. So that's what makes this pretty darn amazing, actually. If you have 4 grand a year for the first 10 years. So, 4 grand a year for 10 years, that's obviously $40,000. Well, our account is 1.3 million, and then we subtract the 40,000. So the interest that we got was, about 1.3 million, and that's pretty darn good for paying $4,000 a year for 10 years. Of course, that was you start out very young. But if that was one takeaway that I could give you for this particular example, is that this particular formula here, we use it all the time. It's our simple interest formula here. Um, the more money you start with, the better this looks. So let me just change this up and put it like something like $5,000, right? So if I invested $5,000, 0.085, and then 30 years, right? So if you start with $118,000, that you're doing pretty darn well, and then you'll have 1.3 million when you're 65. Well, let's say that let's say you're me. Let's say you might have $5,000 to your name, and you invest it at this interest rate for the next 30 years. You only end up with $57,000. So that's not that great. I mean, it's still money that I can just sit on, but money makes money, and of course, I'm sure you've heard that before. But anyways. That concludes today's lecture.